Waidsum Academy. Today we'll be looking at chapter 15, Maths IGCSE, IGCSE Mathematics, Cambridge IGCSE. Let's quickly take a look at chapter 15. And our topic is sequences. Sequence is same as progression, okay? When we say sequence, another name that is used for sequence is a progression. It's progression. So we can say sequence or we say progression. We say slash progression. Okay. In the past we were saying progression. You have arithmetic progression, geometric progression. We have you remember we have different type of sequences. So, but we're going to take them one after the other. Especially we started with the arithmetic sequence. Especially starting with what we call the arithmetic sequence, or what we call the arithmetic progression. So sequence is like a progression. Is that okay? Now, so if we are asked to define sequence, sequence is just a collection of items arranged in a specific order. Okay? If I arrange numbers in a specific order, then they can be sequence. If I write even numbers, then we can call it sequence. For example, if I write 2, if I write 4, if I write 6, if I write 8, so what you observe here is that we are adding 2 to every number. So the next number is to add 2 to the previous one. So you get the next one. So it's a sequence, it's a pattern. Sequence is like a pattern. Okay? The occurrence of the numbers are in a pattern. So from these numbers, you can see the next one is obtained by simply adding to the previous one. By simply adding to the previous one. So that's what sequence is about. So collections of numbers in a specific order. Okay, now let's take a look at some of the examples. You have the first sequence here. You have 2, you have 4, you have 6, you have 8, you have 10. You can see this even number, and the progression is the addition of 2 to the previous number. The addition, the next term, every number in the sequence is called a term. Every number in the sequence is called what? A term. So to get the first one is the first term, and to get the next term is to add if it's an arithmetic sequence, we find the common difference. Okay, we're going to talk about the common difference. Okay, the common difference between this first sequence is 2 plus 2. So the first term plus 2, you get second term. Second term plus 2, you get third term. Third term plus 2, you get fourth term. Fourth term plus 2, you get fifth term. Now for this sequence, we take a look at this one. It's a square number. This sequence is a square number. 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25. So this sequence, the definition of the pattern is square number, the square of natural counting number. Okay? Now if you take a look at this sequence is a geometric sequence, this one. This one is not addition, it's multiplication. Multiplication by 2. 2 times 1, the first one is the first term of the sequence is 1. 2 times 1, you get 2. 2 times 2, you get 4. 4 times 2, you get 8. 8 times 2, you get 60. 60 times 2, the next one should be 32. 32 times 2, 64. So this one is a geometric sequence or exponential sequence. It's not an arithmetic sequence. Okay, this is not an arithmetic sequence. Now you take a look at this one. We have quadratic sequence. We have cubic sequence. So I'm going to today, if we get to quadratic sequence, I'm going to show you the trick. The short way of doing quadratic sequence, not as long as we did it in our previous video. Okay, so we have trick, short way, what you should memorize, what you should know that will enable you to do the geometric sequence very easily. Okay, so for this we can write U1 is the first term. We can use U for first term, and U1, U2 is the second term, U3 is third term, UN will be n term. Okay, so for this sequence, 2 is U1, 4 is U2, and so on and so forth. Is that okay? Now let's talk about arithmetic sequence like we've mentioned. In arithmetic sequence, there is a common difference. There's what? A common difference. What do you mean by common difference? This is the first term, 3 is first term, 6 is second term, 9 is third term, 12 is fourth term, 15 is fifth term. Now, what you observe is that from first term to second term, there's a plus 3. Meaning if you add 3 to this first term, you get 6. And then from here to the next one, you have to add 3 to this second term. Plus 3, you get 6. And it's same. The number that we add is same. It's called a common difference of 3. So 9 plus 3, you get 12. 12 plus 3, you get 50. Even if they want the next one, I'll say 50 plus 3, I'll get 18. 18 plus 3, I'll get 21. 21 plus 3, I'll get 24. So that's the pattern of the sequence. It has a common difference. So for all arithmetic sequence, we have what we call the common difference. For all arithmetic sequence, we have what we call the common difference. Now take a look. Let's take a look at this one. This increase ascending sequence. Now let's take a look at this descending sequence. This one is reducing. This sequence, the number is decreasing. Now you see a pattern. To get in arithmetic sequence, if you want to find the common difference, you say second term minus first term. If you want to find the second difference, the second term minus first term, meaning 6 minus 3, then you get the second term minus first term, you get the common difference. You get what we call the common difference. Is that okay? You get the common difference, D. Is that okay? So that's that. Same with third minus second. So you can say D same as also third term, U3 minus U2. The same thing you're going to get, U3 minus U2, meaning second term minus first term, you get what you're looking for, you get the common difference. Is that okay? Because if you say 9 minus 6, you get 3. 12 minus 6, fourth minus third, you also get the same common difference. Fifth minus fourth, you get the same common difference. Okay? Now for this one, if you want the common difference, you say 2 minus 7, you get negative 5. See? 2 minus 7, you get negative 5. This one, negative 3 minus 2, you get negative 5 also. Negative 8 minus 3, because this one is minus and there's another minus. Minus 8 minus 3, you get negative 5. Negative 13 minus 8, you get negative 5. So this one, the common difference is negative 5. Is that okay? Okay, so arithmetic sequence has a formula. Okay, it has a formula. So to get the next term, you just add the common difference to the previous one. To get the next one, we add the common difference to the previous one. We have one sequence, we have one formula, which probably for some of you, the n term of arithmetic sequence. We always say the n term is given as, okay, this formula is different from this author's way. N term is A. A we call the first term for this formula, we call A the first term. A plus bracket, n minus 1, D. N minus 1 multiplied by the common difference. Okay, we use this formula to calculate the n term. Okay, we're also going to follow this author's formula of calculating the n term in the sequence. Okay, now let's move ahead quickly. Now, it said the term to term rule. Look at, it said the term to, let's take a look at term to term rule. Look at this sequence. We have 7, we have 12, we have 17, we have 22. So if you look at the sequence, the common difference is what? Plus 5. The common difference is plus 5. So the term to term rule is plus 5, right? That U2 equal to U1 plus 5. If you want the second term, you say first term plus 5. If you want third term, you say second term plus 5. So if you want third term in this text, we're using U3, right? If you want third term, you say U2, which is second term, U2 plus 5. Okay, simple way, U2 plus 5. You get the third term, U2 plus 5. If you want, let's say, 20th term, you say U20 will be equal to 20th term, you say U20 is equal to U19 plus 5. U19 plus 5. So it's always like that to get the next term in a sequence. So the sequence, you just need to know the common difference. You start adding the common difference to the previous term. Okay? First term is, second term is first term plus the common difference. That's all, and so on and so forth. Is that okay? So we said U1 is 7. U1 is 7. The first number in the sequence is called the first term. It's called the first term, and it's called U1. Okay? U1 is 7. So UN is the n term, right? N term of the sequence. So, and UN plus 1 is the term after the n term, right? So if you want to find UN n plus 1, it will be equal to UN plus the common difference. UN plus the common difference. Okay, now let's move on quickly. Let's take a look at another case where we have the position to term rule. How we can use the position term rule to find the n term. Because in the exam, you have this one in the table. They want you to find the n term, to write the n term. So a formula for the n term, apart from the one I gave you just now, apart from this one, there is a quick one. Okay, there's a quick one. Apart from this one, there is a quick one that can help us. There's a quick one that can help us solve this problem. Now let's go for position to term rule. Now let's go to look at position to term. What do you do? Tell me to stop. What you do in position to term rule is to first of all find the common difference. To find the common difference, to look at this is the first term. This is just position 1, position 2, position 3, position 4, position 5. First term is 7, second term is 12, third term is 17, fourth term is 22, and fifth term is 27. So what we do is to find the common difference. To find the common difference is to find the difference between 12 and 7. So you say 12 minus 7 will give you 5. So we see that here is plus 5. We see that here is plus 5 as our common difference. You have to see whether it's the same. You cannot just do one and say, oh, common difference plus 5. 17 minus 12, also plus 5. So you have to test for all. And then you know, okay, this common difference is plus 5. 22 minus 17, you get also plus 5. Okay, now we can be rest assured that this common difference is positive 5. 22 to 27 is plus 5. So we can see that it's all plus 5. So our D is equal to 5. Our common difference is 5. So we can write it somewhere here. Our D common difference is equal to 5. Now that we know that our D is equal to 5, now that we know the common difference is equal to 5, what we do, please pay attention. This is what we're going to do now. How do we find the n term? Look, it looks like magic. I want to show you how we find the first term from the table. Now you know the common difference. You're going to take the common difference multiplied by the position. Common difference multiplied by 1. That's 5 multiplied by 1. If you don't pay attention, you don't know how I did it. 5 multiplied by 1 is 5. Now, 5 multiplied by 1, 5 times 1 is 5. 5 times 1 is 5, right? So what we make it to be equal to, 7. You know the position is 7. The term in that position is 7. So I will say plus what? Plus 2. 5 plus 2 will give me 7, right? 5 plus 2 will give me 7. So we're going to use this logic to find the n term here. We're going to use that same logic to find the n term. How? Same you're going to do here. 5 times 2, we don't need, once you do the first one, you can even come here straight away. The first one is to help you know how to do the n term. The second one will give you the same thing. 5 times 2, you get 10, right? 5 times 2, you get 10. But if you add 2, you'll be 12. 5 times 2 is 10. Then if we add 2, we get. So we use the common difference to multiply the position, and then we add 2 to get the term. 5 times 2 is 10, plus 2, we get 12. So since I already know it, n term will now be what? N term will be what? 5 times n. So here I will have 5 times n, which is 5n plus 2. 5n plus 2. Finish my n term. 5n plus 2. That will be the n term. You see? It's easy. 5n plus 2. See, if you want to check it, we can use that formula I stated. When I say n term is equal to, when we said n term is equal to a, which is first term in the sequence, is equal to a plus, we want to verify a plus n minus 1, when we say a plus n minus 1, multiplied by the common difference. Remember, this was the formula I said you can use to find the n term. But for position rule, it's very easy. We just find the common difference. We use the common difference to multiply the position. And then we see which number, whatever here is, which number can we add to it to get what is here. And then that becomes our n term. Now, first term here is 7. So I put 7 here. If I put 7 here, I say plus. We don't know. We are looking for n term, so we don't know the value of n. So just write n minus 1 in the bracket. Multiply by the common difference, which is 5. So we're going to multiply with 5. So 5 times n, you take this 5 to multiply n, you get 5n. So we get 5n Okay? Remember there's 7 here. We're going to write the 7. We're going to write the 7. We'll get 5n. Then 5 times negative 1. 5 times negative 1, you get negative 5. You get negative 5. Now let's do the one with n first. So you write 5n down. You write 5n down. Now 7 minus 5. You see this number? You now do them together. It's not going to become plus because you are not crossing equality sign. It's one same expression. So you just say 7 minus 5, you get 2. So we get plus 2. So you can see this is the end term of the sequence. This is the end term of the sequence, which we did very easily from the table. Which we did what? Easily from the table. So we can use the table to find the n squared. How? Even if they did give you a table, if they give you a sequence, you can make it in tabular form. First one, put position 1. Second one, position 2, position 3, position 4, position 5, position n. So this one you put, the last one you put position n. So what you do, you say, you find the common difference of the sequence. If the common difference is all same, if it's all same, then it's an arithmetic sequence. If the common difference is all same, then it's an arithmetic sequence. For arithmetic sequence, you take the common difference multiplied by the position. 5 times 1 is 5. You think, what should you add to that number, or subtract from that number to get the first term? So we can see 5 times 1 is 5. So we need to add 2 in order for it to be 7. So we say 5 times 1 plus 2. That's how we got this. So you come here, you say 5 times n, 5n plus 2. This will be the n term, which is, you don't have to solve. You don't have to go a long way. Short way of getting the n term without solving. You see, I solved it. We got the same thing. And I just use the table and I get it faster. So with the table, you can get it faster. So the n term is 5n plus 2. That's it. Now let's take a look at another sequence. Now, for this sequence, let's put the n here. We want to find the n term. Okay? From position, from the table. Now, first of all, what's the common difference? You first of all find the common difference. Always, that's the first thing you do. You check the common difference. If it's same, if the common difference is same, then it's an arithmetic sequence. So for all arithmetic sequence, what do? You take this one, multiply by the position. 4 times 1 is 4. So how will it become 1? So 4 times 1 is 4. How will it now become 1? 4 times 1 is 4. So I have to subtract 3. Right? 4 times 1 is 4. For it to become 1, I have to what? Because it must become this first term. It must turn to this first term. So for it to become 1, I must say minus 3. Right? Logically, nobody tells you this. You do this with logic. 4 times 1 is 4. 4 minus 3 is equal to 1. Right? So 4 minus 3 gives you 1. 4 minus 3 gives you 1. So which becomes it? So it means the n term will be what now? N term will be 4. 4 times n minus 3. 4 times n minus 3. Once you do the first one, you can just go and... The first one is to test what do you add or do you subtract in order to get the first term. Once you get that, you just come here. You say 4 times n, you get 4n. And then you subtract 3 minus 3. 4n minus 3, that becomes your n term of this sequence. So this position to term rule makes it easy to get the n term of the sequence. Okay, 4n minus 3. Makes it, look at it, that's what it got, 4n minus 3. Makes it easy to get. Now let's try this one. Let's take a look at this one. You have first term here 7, 9, 11, 13, 15. So what do you have? Common difference of 2. Now, we say the common difference, you take the 2, multiply by 1. So, 2 multiplied by 1, you get what? You get 2. 2 times 1, we get 2. So, but that's not 7. What should I do? 2 times 1 is 2. So, what should I do to it to make it 7? I have to add 5. What should I do to 2 times 1 is 2? What should I do to it to make it 7? I have to add 5. So, I'll say plus 5. So, I say plus 5. That's what I should do to it to make it 7. So since I have got it how this one is, the same thing I'm going to do for the n term. So I come here. If I'm looking for the n term, I put n here, position n. I call it position n. So I'll say 2 times n. I'll say 2 times n plus 5. I'll just say 2 times n plus 5. 2 times n. You must test it with the first one before you come and do the n term. I say 2 times n plus 5. So this will be the n term, which they wrote here, 2n plus 5. to n plus 5. So if you want to, in the exam, they give you a table like this. They want you, once it's arithmetic sequence, this is how to get. Now let's try this one. This is a descending sequence. Any descending sequence, the common difference will be a negative number. Any descending sequence, this you can see this is going down with 3. 12 reduces to 9, meaning it's going down by 3. 9 reduces to 6, it's going down by 3. 6 reduces to 3, it's going down by 3. 3 goes to 0, it's going down by 3. The next term will be negative 3. The next term will be negative 6. The next term will be negative 9, it's going down by 3. Okay, so the common difference is negative 3. Now how do we find the n term? You first of all come, you say negative 3 times 1. Negative 3 times, to find the n term, you first do with the position 1, first position. Negative 3 times 1 is equal to negative 3, right? Negative 3 times 1 will give you negative 3. So what should you add to make it 12? Negative 3, what should you add to make it 12? I have to add 15. I have to add 15. Because minus 3 plus 15 will be 12. Minus 3 plus 15 will be 12. So once I get that, then I come and do my n term. I put n here. So I'll say negative 3 times n, I get negative 3n. Negative 3 times n, I get negative 3n. And then I'll say plus 15. That's it. My n term is negative 3 plus 15. Okay, for arithmetic sequence. Okay, so once you know this trick, it's very easy for us to calculate the n term of any arithmetic sequence. Now, the last but not the least for this type, before we give you some questions to try, the last but not the least, you take a look at this. Every sequence they give you, remember, is the term. These are just position 1, 2, 3, 4. The first column, or the first row, is just position number. Okay, it's not the sequence. The sequence is the term. The one you see the right term is the sequence. 12, 7, 2, negative 3, and negative 8. This is the sequence. But these ones are just position. Position 1, position 1, position 2, position 3, position 4, position 5. Now, the first thing you do is to find the common difference of the sequence. You can see the sequence. Remember how to find common difference? You say 7 minus 12, you get negative 5. 2 minus 7, you get negative 5. Negative 3 minus negative 2, you get negative 5. Negative 8 minus minus, negative 8 minus 3, you get negative whatever. Is that okay? So you get negative 5. So you can see it has a same common difference. Since it has same common difference, what it means is that if it has same common difference, it means it's an arithmetic sequence. Since it's an arithmetic sequence, what we do to find the n term, we first take the common difference to multiply the position. Negative 5 times 1, you say negative 5 times 1, you get negative 5. Negative 5 times 1, you get negative 5. So how will it become 12? Negative 5, what will you add to negative 5 to become 12? What are we going to add to become 12? I have to add something, a number bigger than 12, right? To make it 12. I have to add a number as big as 17, okay? Because minus 5 plus 17 will become 12. Minus 5 plus 17 will become 12. So since we already know it from here, then you come and use the same trick here. You write the n term here, you write n here. You write n for the n term. Then you say minus 5, which is the common difference, multiplied by n. You get minus 5n, then plus 17. You get minus 5n plus 17. Is that okay? You get minus 5n plus 17. That becomes the n term of the sequence. That becomes the n term of the sequence. Okay? So with this, you pause this video at this junction and calculate whatever and however. They give you a table, they can ask you to fill it up. They can ask you to fill it up and put everything in the sequence. Good. Okay? So here you can see this sequence. They ask us to find the n term. They ask us to find the n term. This is what they give you the n term. They want you to find the numbers here, blah, 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 all the numbers here. Okay? So all the numbers here. They give you the n term. You already know the n term. So if n is 1, if n is 1, if n is 1 and n plus 3, what do you get here? 1 plus 3, you get 2 here, right? So whatever. You start to use this one to calculate all the numbers here. Is that okay? So pause this one and do the next one. So the next one, with this we come to the end of part 1. Part 2, we're going to take the quadratic and the cubic sequence. Thank you for joining us. Thank you.